When we talk about the Shenyang J-15 flying shark, the first thing that usually comes to mind for many observers is one word: copycat, or perhaps knockoff. Critics look at the canards, the twin tails, the folded wings, and they dismiss it as nothing more than a reverse-engineered, unlicensed clone of the Soviet Su-33 Flanker D. It's an easy narrative. It's comforting for Western analysts, but it is also dangerously wrong. While the airframes may share a silhouette, what lies beneath the skin of the J-15 tells a very different story. This isn't a story of mere imitation. It is a story of a desperate, high-stakes gamble to build a blue water navy from a pile of Cold War scrap metal. To understand the J-15, we have to go back to 2001. The location: a dilapidated hangar in Crimea, Ukraine. Inside sat a relic of the collapsed Soviet Empire, the T-10K3. This was the third prototype of what would become the Su-33. By the time Chinese delegations arrived, it had been rotting for a decade. The canopy seals had failed, letting in moisture. The hydraulic struts were leaking black sludge. Critically, the avionics, the flight control computers, and the radar systems had been stripped out or were non-functional. To Western intelligence agencies, it was industrial garbage. At the time, Russia was operating its own small fleet of Su-33 and was willing to sell them to Beijing, but with a catch. They demanded a minimum order of 50 aircraft, with zero technology transfer and no access to the source code. It was a classic take-it-or-leave-it deal, designed to keep China dependent on Russian aerospace technology forever. China chose the hard road. They bought the scrap metal from Ukraine. They brought the T-10K3 home, not to fly it, but to dissect it. The goal was audacious: to reverse engineer the complex aerodynamics of a heavy carrier fighter without the benefit of the original wind tunnel data, stress test records, or manufacturing blueprints. It was a gamble that many Russian experts predicted would result in a Hangar Queen, a plane that looked like a fighter but couldn't fly like one. Let's address the elephant in the room. The J-15 looks exactly like the Su-33. Why? Because when it comes to carrier aviation, physics is a cruel mistress. The Su-33's airframe is a masterpiece of high-lift aerodynamics. The combination of the unstable, integrated wing body design and those distinctive canards creates massive vortex lift. This allows a 30-ton aircraft to claw its way into the air from a ski jump ramp in just over 100 meters. This aerodynamic layout was a result of decades of Soviet research. China's first carrier, the Liaoning, was itself a Soviet hull designed specifically for this type of aircraft. Changing the outer mold line of the jet would have introduced massive, unnecessary risks. Why reinvent the wheel when the wheel fits the track perfectly? But here's the critical analyst takeaway: a shared shape does not mean shared capability. You can put the motherboard of an iPhone 17 into the casing of a Nokia brick phone. They might look similar on the outside, but one is a communication device, and the other is a supercomputer. China kept the shell of the Su-33 because it respected the laws of aerodynamics. But everything inside that shell, the skeleton, the nervous system, the brain, has been subjected to a complete genetic modification. To appreciate the J-15, we must first understand the limitations of its ancestor. The Su-33 was a product of the 1980s Soviet Union, a superpower in decline. It was a single-mission aircraft: take off, intercept American bombers, and land. It suffered from three fatal flaws. Avionics: it used the N001 mechanical pulse-Doppler radar. Heavy, prone to clutter, and easily jammed. In a modern electronic warfare environment, it is effectively blind. Control: it relied on an early analog fly-by-wire system. While advanced for its time, it lacked the precision and carefree handling protections of modern digital systems, making carrier landings, already the most dangerous job in aviation, even more perilous. Weight: lacking advanced composites. The Su-33 was built largely of aluminum and steel. This heavy empty weight severely penalized its fuel and weapon load for ski jump takeoffs. The few remaining Russian Su-33 are largely operational relics today, limited by these Cold War constraints. This is where the story shifts from copying to innovating. Shenyang's engineers gutted the T-10K3 concept and rebuilt it using 21st century Chinese technology. The J-15 uses a fully digital, indigenous fly-by-wire control system. This is the holy grail of modern flight. It replaces heavy hydraulic linkages with light-speed fiber optics. The flight computer performs thousands of calculations per second, allowing the pilot to pull aggressive maneuvers without stalling and, crucially, automating much of the carrier landing process. This stability is a massive force multiplier. The mechanical radar is gone. The early J-15 fielded advanced post-Doppler radars, but the latest variants, the J-15B and the catapult-capable J-15T, are equipped with AESA radars. An AESA radar has no moving parts. It scans electronically in milliseconds, resists jamming, and can track tens of targets while guiding missiles to multiple bogies simultaneously. While the Su-33 is still looking for targets in the snow of electronic noise, the J-15 has already locked on and fired. China has made massive strides in material science. The J-15 utilizes extensive carbon fiber composites in its wings, tails, and control surfaces. This reduces weight by hundreds of kilograms compared to the Su-33. On a carrier deck, weight saved on the airframe is weight gained in fuel or missiles. This seemingly small change directly translates to longer range and more lethality. Perhaps most importantly, the J-15 carries modern weapons. The Su-33 was limited to the R-27, a semi-active radar missile that required the pilot to keep flying toward a target to guide the weapon. The J-15 carries the PL-12 and the long-range PL-15. These are active radar fire-and-forget missiles. The pilot can fire and immediately break away or engage a new target. Combined with the YJ-83K anti-ship missile and the YJ-91 anti-radiation missile, the J-15 is a true multi-role strike fighter, not just an interceptor. But the biggest difference isn't in the plane itself. It's in the network. A carrier fighter never fights alone. The Su-33 was designed to operate with the Kuznetsov, a ship with limited command and control capabilities. The J-15, however, is a node in a network battle force, using high-speed tactical data links. The J-15 shares target data with the Type 055 destroyers, the KJ-600 airborne early warning aircraft, and even submarines. This enables capabilities like A-Shoot-B Guide, where a destroyer launches a missile that is guided to its target by J-15 miles away. This level of integration transforms the J-15 from a lone wolf into a pack hunter, backed by the sensing power of the entire fleet. The story doesn't end with the current J-15. Its evolution is ongoing, and it is about to take a quantum leap with the introduction of the J-15T. The T stands for catapult. This variant features a reinforced nose gear designed to hook into the electromagnetic catapults of China's new supercarrier, the Fujian. This changes the physics of the fight entirely. Ski jumps limit takeoff weight. You trade fuel for missiles. But with MOs, the J-15T can launch at maximum weight, full internal fuel, and a full load of heavy anti-ship or air-to-air missiles. It unlocks the true potential of the heavy flanker airframe, long-range, high payload, and massive endurance. It will serve as a heavy bomb truck and standoff striker, complementing the stealthy but payload-limited J-35. So, is the J-15 a copy? In shape, yes. In spirit and capability? Absolutely not. It is a textbook example of latecomer's advantage. By studying the Su-33, Chinese engineers identified its flaws and fixed them using modern technology that the Soviet Union never possessed. The J-15 represents a massive industrial achievement. It proves that China can not only reverse engineer complex aerostructures, but can evolve and improve them into a native platform that sits at the heart of a 21st century carrier strike group. The Flying Shark is not a rusty relic of the Cold War. It is a modern networked, AESA-equipped predator. And this leads us to the ultimate question for the future of naval warfare. And I want to hear your thoughts in the comments. The question: in a future conflict, how does a heavy, non-stealthy, but long-range and heavily armed fighter like the J-15T stack up against a stealthy, but shorter-range and payload-limited fighter like the F-35C? Can the J-15T's massive missile capacity and support of a networked fleet allow it to overwhelm stealth fighters through sheer volume of fire and sense of fusion? Or is Stealth King, rendering the heavy flanker obsolete before the fight even begins? Are you team payload or team stealth? Let me know below.